I'm at 60. In this video we're going to introduce section 1.4 where we learn and discuss some of the basic rules of algebra. So first let's recall what we mean by an algebraic expression. This is a combination of variables and numbers using the operations of addition, subtraction, multiplication, or division, as well as possibly powers called exponents or roots. A variable, remember, is a letter such as x or y, and it's used to represent numbers. It's used to represent quantities that can vary. So for example, these are each an example of algebraic expressions. We talked about this in class together, right? These are each algebraic expressions. They are not equations, remember, because there is no statement about an equality, so they're just expressions. We're able to evaluate an algebraic expression because we can replace the variable with some kind of a number. And when we do that, we are evaluating the expression. So for example, if we have the expression 2x plus 5, we can evaluate it when x is 3 by allowing x to equal 3 and finding the result of the value of the expression. The expression here would be 2 times the value of x, which is 3, plus 5, following order of operations, tells me 6 plus 5, which is not 13. That's an error on our slide, correct? I'm not reading that incorrectly, am I? When you evaluate this expression, you plug in 3 for x. Order of operations says you should multiply. 2 times 3 is 6. 6 plus 5 is 11. That's not 13. Error in the slide. I don't write these, so that's not me making that error. So notice that should be an 11 right there, not a 13. All right, so just a little bit more vocabulary here. You may have heard the word terms of an algebraic expression before. Terms just refers to those parts that are separated by addition. So for example, in the expression 2x plus 8, the 2x and the 8 are both terms. So we would say that this expression has two terms because the 2x and the 8 are separated by the operation of addition. If this was a division or a multiplication or something right here, then this would be just one giant term because there are no expressions separated by addition or subtraction. A coefficient is the numerical part of a term. So in the term 2x, 2 is the coefficient. It's the number living in front of the x. Like terms are terms that have exactly the same variable part. It means that the variables in that term are exactly the same. For example, 5x and 8x are like terms because they are talking about the same kind of variable. You can think of this instead if you were talking about apples. 5 apples and 8 apples, those are considered like fruit because they're talking about the same kinds of fruit. 2 bananas and 7 bananas, those are like fruit, and so we could combine them. That'll be the sort of preview of our next slide, right? So we could say 2 apples and 3 bananas, they're not like fruit, are they? No, they're different kinds of fruit. So similarly, 2x and 3y, they're not like terms. Okay? So once we have this idea of like terms, we'll be able to combine them later on. But let's discover some of the properties of algebra we're going to need to sort of manipulate and mess around with algebraic expressions. So we have a commutative property of algebra. Commutativity for addition looks something like in this first box, right? It just says that the order of the addition can be reversed. 2 plus 3 is the same thing as 3 plus 2. That's commutativity of addition. 10 plus 4 is 4 plus 10. When you use this idea of commutativity of switching the order with multiplication, that's over here in the second box here. 2 times 3 is the same thing as 3 times 2. The parentheses here are implying a multiplication. You can also use a dot, like is used down here. Try not to use an x to imply multiplication since we're going to be having variables now, and x's are one of our most common variables. Okay, so commutativity of addition, commutativity of multiplication, the order can switch around. Notice that this doesn't work for subtraction because 2 minus 3 is not the same thing as 3 minus 2. So subtraction is not commutative, and neither is division. 2 divided by 3 is not 3 divided by 2. Okay, so commutativity only works for addition and multiplication. We also have what's called associativity, which just says that if you have some grouping going on here, the parentheses can be grouped around different objects and the value stays the same for the expression. If you first added 3 plus 2 and then added 4, that's the same thing as if you added 4 and 3 and then added 2. This also works for multiplication, right? A string of multiplication, it doesn't matter how you multiply. 6 times 4, then times 11 is the same as 4 times 11, then times 6. Okay, we won't use that one a lot, we'll use it a little bit, but we will use the following one a lot, and continuing on into 65 and 95 and 111, the distributive property here says that if you have a number living in front of a set of parentheses, then you should distribute that 7 or whatever it is living here in front to each of the terms living inside of the parentheses. Notice I use the word terms, right? The stuff inside the parentheses here has 2 terms. The 7 needs to multiply both of them because this is a multiplication parentheses here. Yes, so the 7 needs to multiply the 2x as well as the 3 to get 14x plus 21. And it doesn't matter if you have 2 terms inside the parentheses or if you have 3 or if you have 7 or if you have 11, it doesn't matter. So here it says that the 5 needs to multiply by 1, 2, 3 terms inside of here because they are separated by subtraction. So the 5 multiplies by the 3x to get 15x, the 5 multiplies by the minus 2 to get minus 10, the 5 multiplies by the minus 4y to get minus 20y. And the distribution can actually look like reversed like it does here, where this still says multiply, but it just means that the 4 needs to multiply to both of the terms living inside the parentheses. Yes, it just multiplies left like that. Excellent. All right, now let's get to the idea of what's called combining like terms. If we're going to combine like terms, we just add or subtract the coefficients of the terms. For example, 7x plus 3x. If I had 7 apples and I wanted to add 3 apples, how many apples do I have? Well, you just combine the numbers of apples you had before. That would be 10 apples, correct? And that's exactly what we're doing here. Instead of apples, we're talking about x's, though. The terms are like terms because they have the same variable. Remember, they're both x and x, some number of x and some number of x. Therefore, to combine them, you just add the coefficients. 7 plus 3 is 10, right? 7 apples and 3 apples would be 10 apples. This is the new coefficient of the combined term here, the 10x. So let's look at an example to finish off our fairly short little video here. Let's simplify the following expression because I see that there are some operations implied here and some parentheses, and we'd like to combine like terms. So we start out with the entire expression. This is not the solution yet. There's still some more stuff to happen here. We start out with rewriting exactly what I had before. The first thing we're going to do is notice that this set of parentheses here, we need to work first by order of operations. So we are going to see if we can combine anything on the inside of the parentheses. We can't because it's an A, a B, and a C. They're all different. It's apples, bananas, and cherries, or whatever you want to call it, carrots. But what we can notice is that there's a negative out front that could be, by the distributive property, applied to each of the 3 terms that lives inside of the parentheses. So this positive 2a becomes a minus 2a. This positive 4b becomes a negative times positive is negative. This negative 6c becomes negative, and negative makes positive. Remember that the negative just does what? Changes the sign of everything on the inside of the parentheses. Okay. Once we have that done, we can now try to use commutative and associative properties to reorder everything. We want to put the a's, the b's, and the c's near each other, right? So the 3a and minus 2a are grouped together here with some parentheses. We want to put the b and the c's together, right? Positive 6b, it's right there, and minus 4b, right there, are combined here and sort of held together by these sets of parentheses. The 6c and the minus 3c are brought together over here because we're setting ourselves up for combining like terms. Okay, it's okay to reorder, remember, the list of things here because addition is commutative. You just have to make sure you keep the sign with the correct term. For example, 4b should be a negative term, just like it is here. Now we combine like terms. We're going to subtract the coefficients here. 3 minus 2, that's the number of a's we have. 6 minus 4 will be the number of b's we have. And 6 minus 3 will be the number of c's we have. Okay. If you don't want to do this step, that's fine. Technically, we didn't have to do this step either, but if you're not comfortable with omitting either of those 2 steps, then please feel free to go ahead and do so. Go ahead and do them. So we have 1a, we have plus 2b, and we have plus 3c right there. And usually, by the way, we don't write the 1 in front of a variable like this. We usually just write it as a, okay, instead of 1a. Just like that. All right, so that is the end of our video for section 1.4. On to section 1.5.